Here we are asked how many six-letter words can be formed using the 26 letters of the English alphabet if repetition of letters is or is not allowed. Here we're going to use the fundamental counting principle. The fundamental counting principle says that if an event is composed of sub-events, then the number of ways that the event can occur is the product of the number of ways that each of the sub-events can occur. So in this case, we're looking at creating six-letter words, but each six-letter word is created by first of all choosing a first, then a second, third, fourth, fifth, and sixth letter. And so these are the six sub-events. When repetition is allowed, each of these letters can be chosen 26 times. And so the total number of ways that six-letter words can be created when repetition is allowed is 26 to the sixth power. Now, if repetition is not allowed, there still are six sub-events, but this time it's only the first sub-event that can occur 26 ways. When we choose the second letter, we only can choose from 25. The third from 24, fourth from 23, fifth from 22, and sixth from 21 letters. And so this product will give us the number of ways that we can create six-letter words if repetition is not allowed. Now, in this case, we also call that the number of permutations of 26 items taken 6 at a time. And it is also denoted with a capital P parentheses 26, 6. We're going to see more examples of permutations in the later videos. And so let's look at the next example where we're going to use the fundamental counting principle. And in this example, we're wanting to find the number of telephone numbers with 10 digits that can be created if there is a restriction that the first and the fourth digits can be neither 0 nor 1. So the first position, we have 8 digits to choose from. The fourth, we have 8 digits to choose from. All the other positions will have 10 digits to choose from. Therefore, the number of possible telephone numbers with these conditions is 8 squared times 10 to the 8th, which is 64, followed by 8 zeros, which is 6,400,000,000 telephone numbers. And we have one more example we're given a red die and a white die. These are both rolled, and we want to know how many different outcomes are possible. This time we can think about, for the red die, the numbers 1 through 6 are possible, and for the white die, the numbers 1 through 6 are possible. And so this time we can see that for the first die there are 6 possible outcomes. For the second there are 6 possible outcomes. So there are a total of 36 possible outcomes here. So notice that because we do have a red and a white die, then the outcome, for example, 2 on the white die and 1 on the red die is different from 1 on the white die and 2 on the red die, etc. And so all 36 outcomes are discrete in this case. So the number of possible outcomes is 36.